have seen physical equilibrium. Physical equilibrium attained due to the physical changes. Similar to that, if an equilibrium attained due to chemical changes or chemical process, we can call it as chemical equilibrium. So here you can see if the opposing forces involved only in chemical changes, then we can call it as chemical equilibrium. So chemical equilibrium is mainly two types, reversible and irreversible. We know what is reversible reaction and irreversible reaction. Reversible reaction. If a reaction occurs reversely, we can call it as a reversible reaction. For example, here given as the formation of Fe3O4. So we know in the formation of Fe3O4, the iron, that is Fe, and if we dissolved iron in water, we'll get Fe3O4 and hydrogen gas. So in this reaction, we can convert Fe3O4 into Fe on water. So there is forward reaction and backward reaction. Under the same condition, we can do this. So a reaction which takes place not only in forward direction but also in backward direction, then we can call it as a reversible reaction. For example, in the physical, it's in the case of it is a physical change, not a chemical change. We know ice can melt and gives water. Water can freeze, will get again ice. So it is also an irreversible reaction, but it is a physical reaction. But in the case of chemical reaction, if it is occurs reversely, then we can call it as a reversible reaction. Okay. Then what will be the irreversible reaction? Irreversible reaction is the reaction in which a reaction which cannot take place in the reverse direction. That is, the product's forms do not react to give back the same reactants under the same conditions. If we take in first example here, Fe3O4 can be again converted to Fe and water in the same conditions. If we apply the same temperature and pressure, we will get the same reactants again. So the reactants, so if we here you can see, here you can see Fe3O4 can be converted to Fe and water. Another example is, we know water, if we make water from produce or applying any force on hydrogen and oxygen, it will convert it to water. If we do electrolysis in water, it will convert it to H2 and O2. So it is also a reaction. So same condition we can do that, but in the case of Fe3O4 also we can do, but in the some reactions, if here, so the reactants converted to products converted to reactants, so it is occurring simultaneously, then only we can call it as a reversible reaction, and if you can call it as a reversible equilibrium. But in the case of irreversible reactions, a reaction which cannot take place in the reverse direction, only forward direction, not in the reverse direction. That is, reactants are joined together or combined together or react together to give the products. The products will not convert to the reactants again. For example, magnesium and oxygen combined together to give magnesium oxide. We cannot further, in the same conditions or in the same conditions such as same temperature and same pressure, we cannot convert magnesium oxide into magnesium and oxygen. Such reactions are known as irreversible reactions. And there are so many other examples, and from our daily life you can say, for reversible and irreversible reactions. Then we'll move to the concept of chemical equilibrium. So for example, there is a general reaction given. These are the reactants. A and B are the reactants here. C and D are the products here. A and B combined together to give C and D. So this reaction is carried in a closed vessel. After some time, an equilibrium state. If it is in a closed vessel, there is no change the matter to the surroundings. Only the reaction occurs in the system. So there is no change of matter into the surroundings. So the reaction occurs here only. So after some time what will happen? There will be an equilibrium attained, that is the rate of the backward reaction is equal to the rate of the forward reaction, that is the reactants will convert it to the product, at the same time the products will convert it to the reactant at the same rate. So that we can, in a chemical reaction, if it is occurs, we can call it as the state of chemical equilibrium attained. So the concentration of the reactants and products remains constant. We know concentration is a chemical thing. So here you can see the process of N2O4, gas will convert to NO2, and calcium carbonate converted to calcium oxide and carbon dioxide. If calcium oxide and carbon dioxide, if this reaction occurs in a closed vessel, after first what will happen? The calcium carbonate converted to calcium oxide and carbon dioxide. But after some time, what will happen is the calcium oxide and carbon dioxide mix it together, and they will start to form calcium carbonate, and after some time the forward reaction, that is the calcium carbonate dissociate and the to give calcium oxide and carbon dioxide, that reaction and the association of calcium oxide and carbon dioxide which gives calcium carbonate, these two reactions will be equal after some time. Then we can call it as the state. This state, the forward reaction is equal to the backward reaction. This state we can call it as the state of chemical equilibrium. So here the backward and forward reaction is occurring. So there it is dynamic in nature. There is a movement. That is, as much as the reactants react to form products, then the same amount of products react to give back the reactants in the same time. So it is moving. It is moving. It is forward and backward. So there is a moving process occurs. So we can call it as dynamic nature of chemical equilibrium. So what do we mean by dynamic chemical equilibrium? The dynamic chemical equilibrium is the state of reversible reaction where the forward reaction rate is equal to the reverse reaction rate. That is, there is no net change. We cannot observe any net change. The forward reaction and backward reaction is occurring, so we cannot observe any net change. But the reaction is happening. It is dynamic in nature. And reactions are continuing to proceed in the forward and reverse direction dynamically. However, there is no net change in the amount of product or starting material. There is no change in the starting material and the product. It is also known as steady state, whereas the forward process is equal to the backward process, and the amount of reactant is equal to the amount of product, and amount of product is equal to the amount of reactant. So it is a steady state. So in the early stages of a reversible reaction, the forward reaction proceeds. First, the forward reaction will happen, and before reaching equilibrium, then the backward also happening, and after some time, the equilibrium attains. We'll see an example. Ice and water example is given here. So moles of A and moles of B. So this is at the starting condition, the reactant will be more, product will be less. After some time, what will happen after the reaching equilibrium? The reactants equal to the reactant, the product. So number of reactants, if you count the moles, you will get that. To equilibrium rate, the moles of A is equal to moles of B. If 1 mole of A will transfer here, 1 mole of B will convert to reactant. Reactant converted to product, product converted to reactant. So it is dynamic in nature. So we'll see characteristics of chemical equilibrium. The concentration of each of the reactants and products and rate of forward reaction is equal to the backward reaction. Then only we can say equilibrium is dynamic nature. And it is only happening in the closed system, similar to our physical equilibrium. So chemical equilibrium only attained in the case of both of the reaction direction should be equal, that is forward and backward. It is not affected of any catalyst use. If we use any catalyst, the reaction will not change. These are the characteristics. Here some examples are there. Here you can see equilibrium. So this is the first stage. There will be reactant more, then only product. Here you can see the images of this. So we'll discuss more in next class. Thank you.